Hello everyone. Today I will introduce a recent work from one of our team, which is a retrieval-augmented large language models for financial time series forecasting. This work is led by Mengxi, and I'm the presenter. So in this study, the main task is to predict the direction of stock price movement, whether the price is rise or fall. It is an important task in the financial domain because the individual investigators will use these predictions to make the buying or selling decisions. And the large financial institutions rely on the accurate forecasts of large-scale investment strategies. And it's also a very challenging task because the market volatility and the influence of a lot of unpredictable global events, and is a complexity due to the vast amount of influencing factors. So it's a critical time series forecasting task in the financial domain. Yeah, and in the previous work, the traditional forecasting methods and their limitations is the traditional methods is primarily quantitative and based on the historical price data and the simple financial indicators. And it's limited in capturing complex market dynamics and the semantic connections. It often results in the models that are often overfit to the past data and fail to generalize the new market conditions. That's the reason why I need a method that can adapt to the market complexities and capture deeper insights for the stock price prediction. So after we have the large language models, we can have the ability to process and analyze the large volume of unstructured textual data, such as news articles and financial reports. They're capable of understanding semantic connections and semantic in the text, which is critical for the market prediction. But it also has the limitations. It's an over-reliance on the recent data and the textual sources. It's often neglecting long-term historical trends. So in this study, we proposed a time series RAG framework, which is the first dedicated retrieval system for the financial forecasting, and is tailored to understand and process the complex temporal financial sequence. It integrates deep historical data with the current market insights for robust predictions. And in this framework, we can see there have three key components. The first one is the data store construction, and the retriever training, and the inference. So in the following sections, I will introduce these three sections one by one. And here's a summary of the contribution of this study. So we propose our innovative RAG frameworks for financial forecasting and enhance the training and the testing data sets, use diverse financial indicators selected through the expert consultation and the mutual information analysis designed for the real scenarios. And we also developed a FinSeer, which is a specialized retriever and trained on the enriched dataset with historical price data and leverage the large language models feedback to identify the significant market sequence. And we have a great performance and after the validation. So the proposed RAG frameworks with the FinSeer can achieve 8% higher accuracy than the existing models on the big data 22 datasets. And here's a problem definition in this study. So this study is mainly for the stock movement prediction. And in this study, we treat it as a binary classification problem predicting whether the stock price will raise or fall the next day. And here is threshold setting for the fall, raise or fall. So we use the day and the next day adjuster of the price to calculate the RT. And if the RT exceeds the 0.55%, it will be a trader's raise, and equal to below negative 0.5% will identified as fall. So the reason why we set threshold for using the 0.25 and negative 0.5 is the higher threshold for the rise prevents the misclassifications of minor increase as a significant. And the lower threshold for the fall can capture the meaningful downward trends. So the next I will introduce the first component in the framework, the data construction. So the data construction addresses the limitations of existing datasets and align with the real-world economic analysis. For the stock selection, we select the high trace volume US stocks across the different time periods, 2014 to 15, 17 to 18, and 22 to 23, to reflect the varying market conditions. And for the data collection, we use the Yahoo Finance API to gather daily trading data, including the opening, high list, low list, and adjusted closing price. The daily price movement calculated to serve as a reference answer for the model training and the evaluation. And this table shows the main three data sets we use in this study and the stock amount in the training, validation, and testing set. And they also have the list of the training dates for all sequence and the query sequence. And after we collect the data set, we have the selection of the financial indicators. It's integrated the financial indicators to provide the critical insights into the market behavior that stock price alone cannot capture. So we utilize the mutual information called MI to measure the relationship between these indicators and returns to select the top 20 indicators groups as candidates. And here is how we calculate the score of each indicator groups. In this calculation, we're basically using the probability and density functions of the between the indicators and the returns. So, and the p-axis also shows the marginal probability density of the function x and the marginal probability density function of the RT. And the sequence serialization is we transform the stock price and the financial indicators into a time series format for the model processing. And the query, there are two serialization. One is a query sequence serialization. For the stock, at least 1 year after dataset's start date, we use that to do the query sequence serialization to ensure a robust set of candidate sequence. And after that, we do the candidate sequence serialization. For each candidate sequence, we combine the basic stock information with the financial indicators over 5 days window. And here is an example of the results for candidate sequence serialization. We can see it's included the name of the stock, the date, and the movement, the 5 days included, and the high list of the price. And the next component is the retrieval training. In this component, we trained our retriever and proposed the FinSeer. The retrieval training process, we use a backbone model, StockLLM, a fine-tuned 1 billion parameter large language model, established a baseline for the training. And for the candidate scoring, we use the integration of the large language model feedback to score candidate sequence based on their potential utility in the predicting stock movements. And we use the largest and softmax function to calculate the probability indicating the suitability of each candidate. And after scoring the candidates, we select the candidates uh, after ranking the after ranking them by score and identify the top beneficial sequence as positive and last beneficial as a negative. After that, we also do the knowledge uh, distillation. In this step, we transfer the knowledge from the teacher model, large language model, to the student model, the retriever, and optimizing the retriever's prediction by mimicking the large language model's output distribution. And after the retriever training, we have the inference stage. For the inference, the first step is the retrieval of the relevant sequence by the FinSeer based on the historical significance. And second is the incorporation of this sequence into StockLLM's input context to enrich the model's understanding of market dynamics. And the next step is combining their enriched context with the original query to generate accurate and robust stock movement forecasts. This inference, by integrating the historical patterns with the current data to improve the prediction accuracy. And for the environment setting, we use the 3 datasets showed in the table. So we have ACL 18, have 28,076 query sequence, and the big data 22 have 2,868 queries, and stock 23. There are 4,128 queries. And for the baseline models, to do the framework evaluation, we select the bare stock LLM and the random retrieval as the baseline models. And to evaluate the FinSeer retrievers, we select the instructor large, the UAE, BGE, LLM embedder, and the E5 Mistral as the baseline models to compare with our FinSeer. And to evaluate the performance, we use the accuracy and the Mercius correlation coefficient. It's called MCC. And here are the results. In this table, we can find the RAG framework outperforms both the bare stock LLM and the random retrieval across all datasets. And compare with the bare stock LLM and the random retriever, our FinSeer consistently achieves the best performance we integrate with the stock LLM, showcasing its ability to retrieve valuable sequence that improve forecasting accuracy. And the FinSeer is the only retriever that have achieves a stable improvement over the bare LLM on all datasets. And we also analyze what indicators of all RAG models retrieved. And we can see the blue bar in the figure is the indicators can retrieved from each model. So we can see the FinSeer is the only model that successfully extracts the diverse and comprehensive set of indicators while achieving the good performance. There you can compare in this figure, the FinSeer have much more indicators retrieved than the others. And we also did the candidates movement correlation. We investigate whether the LLM relies on the movement trace of the retrieved sequence to make the prediction. And this analysis is based on the correlation between the movement of retrieved sequence and the LLM's generated results. So comparing the correlation score and the p-value, we can find that there is no significant correlation between the movement direction of the retrieved candidate sequence and the final prediction of StockLLM. So that's results highlighted the LLM's capacity to extract meaningful insights from the complex time series data. And we also use the large device to reduce the dimension and do the indicator sequence visualization. As this graph shows, the dimensions including the adjusted close price, open price, high price, low price, volume movement, returns, and WAP. The green points in this figure represent the movement information are well clustered. Shows that the FinSeer effectively captures meaningful patterns. And this visualization provides deeper insights to complex relationship between the stock movements and the indicators. So here's the conclusion. So in this study, we proposed an innovative RAG framework, introducing the first framework of financial time series forecasting, tailored to the unique challenge of financial domain. And the key innovators, including we use the we fine-tuned the 1B StockLLM, serve as a backbone of the retrieval process, which is a very small size large language model. And we also have the candidate selection strategy. So we utilize the LLM feedback to select the sequence that provide historical significance and enhancing the predictive accuracy. For the training objectives, we maximize the similarity between the queries and the significance sequence, refining the focus on meaningful patterns. And for the performance evaluation, this downstream, our RAG system have a significant improvement than the existing model on the data set we use. So thank you. Do you have any questions?